So hello and welcome to another video. In today's video, we're going to be going through a concept of abstract data type that's really important for paper 4. And that's obviously linked lists. And I think if you have already studied abstract data types in your AS level, you've already come across linked list in some form, knowing its advantages, knowing its disadvantages, how modular it is depending on how modular it is compared to, let's say, like an array, or let's say like a stack abstract data type structure, because of its nodes and the way it connects data together. All right, so in the A2 level, at least in your paper 4, you need to be able to go ahead and code basic linked list structures and know the algorithm and how it kind of works. So let's get started by at least visualizing the problem. So linked list is like a data structure. It's going to be a data type. It's going to be user defined data type, and it's going to contain something called the data, and it's going to call the node value, okay, or the node basically. This data part of the linked list contains the data inside, let's say, the array or the structure actually. And this node is like an address. So let's say the next data is in 6. So this thing is connecting to 6. Okay, let's say 6 is here. Okay, this is 6. And let's say there's a data named 3. And then you've got the next address in data 8. 8 is, let's say, located here. So it's going to be connecting this to 8. And let's say this data for some reason is in 3, and the data here is, I don't know, a 0. So this is, let's say, connecting to here somewhere in the middle where it's like 3, right? This is going to be 8 in our case. And let's say this is -1 and this is -1. So -1 is going to be equivalent to something known as a null pointer, all right? So the null pointer means this is the end of the list. This is the end of list, okay? So this is the end of the list. So that's how you do null pointers. Linked list, also something called free list. So free list is, let's say, a list within a linked list, okay? A list within a linked list. So let's say, for example, you've got a list, okay, with some data in it. So you've got 5. Then let's say we've got, I don't know, 6, and this is an 8. And then this is connecting to somewhere else, okay? And let's say we've got something called a free list, which is within that linked list. Oh, and a linked list also has something called a start pointer, or the start of the list. Mainly it's known as, the start pointer, or maybe, the heap pointer, head pointer, however you would like to call it. So let's say this is the start pointer 1. So it's like just one variable that stores it. And this keeps on changing if you delete stuff and remove stuff from the linked list. We're going to go through specifics very soon. All right, so let's say this is 6 and then this is 8. And then in, let's say after 8, okay? After 8 is, let's say, I don't know, maybe we've got 7 here and then 9. 9 is the start of a free list. Let's see, the free list starts from 5. We're going to put our date. So when we go back to 5 here, 5 is a empty. Let's say there's no data in here. It's -1. Okay. And then this is pointing towards 4. Okay, so this right here is, let's say, 5. This is pointing towards 4, which also has no data. This is pointing towards 3, which has no data. So these lists are used to add data to the linked list. Let's say, for example, I want to add something to this linked list. What would I do? First of all, I want to check that if this linked list has any free lists actually left in it, or empty lists as we like to call it. So empty list. So this is where the empty list starts. This 9 contains the variable for the empty list. Okay, so what we want to go ahead and do is we've got 4 here, and then I don't know. Let's put 3 over here. Let's put 1 more, and then let's say this is the null pointer. This is where the linked list kind of ends. Okay, so if you want to go ahead and put some data into the linked list, all we have to do is let me try to go ahead and change the color. Can we change the color? Yeah, we can. So all we need to do is, let's say we've got the data 5. We start by going through the list, or we have a variable that contains empty list. In our case, it's 5. So all we do is just we go to 5 and update this data to a 5. Okay, let's see, we want to store it like that. Let's say we want to store an ordered data. Okay, we want to go ahead and store, let's say, we've got 5 and then we've got 6. So we've got data, let's say 5.5. So what we want to do is first we want to go to the empty list and go to 5.5. Then what we want to do is make this list point to 5. That means we want to change this pointer value to 5 and change this pointer value to 6, because then we want to go in order, right? That's order insertion into the linked list. We want to go in order. So the order to be maintained, now this is going to point towards this, right? It's like going to specific places in, like, let's say in a map, you're pinpointing location and you're going there order by order, okay? But depending on what your need is. Like, let's say you first need to go to the grocery store to get the groceries. Then you go to the post office to get your letter. Then you come home and you use the groceries to make something. And then you write something in the letter in your home again. And then you go to the post office to post it. It's like sequentially done. You can't make food at your home unless you have groceries. It's kind of something like that. And then once this is done, then all the pointers are still, like, after 8, after 6, we've got 7. 6 is less than 7. So there's no more changing to this. Now what we need to do is we need to change this. This is no longer 5 because 5 is not an empty list. So we need to see what's the next available linked list, which is 4 right here, right? 4. So 4 is the next available linked list. So this data, 4, we keep it in a separate temporary variable. And then what we do is we just go ahead and just point this to the 4, okay? So all we just need to do is just take 9 and point it towards 4. Obviously, I just multicolored it, but you get the point. Now let's move all this mess from the screen, and okay, I'll actually keep the software open so that I can kind of mark stuff up, all right, while doing this. So to do this, we're going to be going ahead and following 2021's question paper. So first, what we need to do is let's take a object-oriented programming approach. What we want to go ahead and do is create a class named node in this case. Okay, I'll just configure my Python interpreter. In my case, 3.1. The latest versions, I think 3.2. Just download the latest one when you're doing it. And inside a node, we are going to be having two things. We're going to be having node parameters and data parameters. All right, and inside this, we're going to be having a node. The node is going to be the specific value that we put into node P, and self.data, let's do a capital D. I know that's not the proper naming convention, but we just try to learn the concept. All right, so with this, we're going to be going ahead and creating a data. Now, if you already go into my GitHub, you're going to be seeing that I've already solved 2021. If you look through my past videos, I've already solved 2021. And you remember a linked list question right here. So let's just go to that repository. And I want to go ahead and take this array, which contains all the data types of type node. Okay, so all we need to do is let's just go ahead and keep it. So we want to go ahead and create an array named linked list. Okay, just a simple name, linked list. So I'm going to be explaining in detail every single part of the algorithm. Okay, so now, as we can see, this would usually be specified in your question, which was in the case of this particular year. This linked list contains, like, this is node, the start node, okay, the start pointer is going to be 0. Okay, so that means this is literally the first node. And our next data is in 1, so we go to 1. The next data is in 4, so we do to 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So this is our next data. Then the next one's in 2, so we go to 0, 1, 2, so it's right here. And then this is not actually ordered, but we are going to be going through ordered insertions and how to kind of add them into the linked list, okay? So don't worry about that right now. And we can see that specific data values inside the node is 0, right? So we want to see that what is our free list, empty list. So we've gone through 2, then we've gone here. So then the next one's 4. So we go to 0, 1, 2, 3, 4. Oh, we got 0. So we've got 1. Then we've got 4. So 4 is going to be 0, 1, 2, 3, 4. So from here we've got a 2. So 0, 1, 2. The next one's a 7. So 0, 1, 2, 3, 4, 5, 6, 7. Then what's the 3? So 0, 1, 2, 3. And then it's -1. So the list ends here. But what we can see that the first 0 value is here. So it's 0, 1, 2, 3, 4, 5. Then if you go to position 6, so we go from 0, 1, 2, 3, 4, 5, 6. It's again another 0. Then if you go to position number 8, so this, if this was 6, this is 7, then 8, it's another 0. And then from 8 we go to 9, so this was 8, so this is 9, this is 0, and we've got a -1. So that's our empty list. So we can go to empty list. Now the empty list could be inside one single linked list, it's joined together, or it could be separate. In this case, we've got a -1, so it's kind of separate. So for empty list, the value is going to be 5. So 0, 1, 2, 3, 4, 5. That's our first empty list value. Okay, so now let's try to see how we can output all the nodes from this. We want to go ahead and get a proper output of all of them from, this value right here, right? So make sure that if you are using private methods, like putting the double underscore in front of it, then you need to use get and set methods. All right, so make sure you can create those. I'm not going to do privates, but it's up to you and actually up to the question on how they actually ask you. If it's private, then make sure you have your getter methods and setter methods ready. Okay, so now what we want to do is let's just call this def output. Okay, we're going to just call this output, right? And then let's say this takes in a linked list itself. So linked list itself as parameter. It also takes the start. Let's call it start where. So from where to start. Okay, so in our case, it's going to be the start pointer. So we want to go ahead and only output the data from the actual linked list, right? So what we want to go ahead and do is, let's say we're going to put something called a current pointer. All right, so we're going to do while start where. So start where. So if this exact thing is not yet equal to -1, okay, that means -1 means that's a null pointer. That's where the list ends. What we want to do is we want to go ahead and print linked list, all right, dot, and we want to also go ahead and forward the position, right? So this is the position, right? Start where. So linked list start where, and at that point, that position, we want to go ahead and print the data, right? That's pretty much it. And then we want to keep updating start where. So what's going to be start where? All right, so let's just try to visualize this once again. So once it starts off from your start pointer, okay, so in this case, it's going to take linked list, start pointer is going to be, it's going to be 0, right? So it starts from 0, it goes to the 0 position and outputs, let's say 5. Then it's going to be going to its next pointer, which let's say it's 6. It's all the way over here, right? In our case, this is going to be, let's say 1, which is, let's say it's somewhere over here. This is 1 right here, right? Let's say this is 1. So it's going to go to 1 and it's going to output the 5. This data should have been 1 because right here it's 1, right? And then it's going to go from there, it's going to go to 4. So it's going to be searching for 4 somewhere here. So this variable needs to be updated with the next node value of the linked list, all right? So that's what we want to do. So all we've got to do is let's just call this start where. This is updated to the linked list's current start where value. So that's the current start where value. So start where value. And it's now updated to the next node value. Okay. So it's updated to the next node value, or the current node value. Okay, so we're just going to call this node, but basically right now start where is 1. That means it's going to update the value of start where with the value of node right here, right? So we're going to update it with node. All right, so we seem to have some sort of issue with the code right here. Oh my god, we've got tons of issues. Node. Oh, okay, so these nodes are small. Why? Because again, we copied it from a previous poster. Okay, instead of changing everything, why don't I just change this to a small node and change this to a small node? That's it. No need to worry that much, right? So I think now everything is resolved, is it? So node, node P, node, node, node. Does look it does look okay to me, at least. start where, linked list start where. That's going to be, kind of in the node area. So it's going to node linked list start where, right? So we still have, I don't think we still have those issues. Unresolved first on node. Let's go on 6. Oh, this is also, oh my god. This node actually really doesn't matter. So let's just keep it big. Oh crap. So that's why we're going to be going ahead and change this to node. There you go. All the errors are automatically fixed, right? Okay. So now it's just going to be outputting. That's the function. That's what it's going to be taking. So that's like printing all the nodes. And that's pretty much it. That's literally outputting all the nodes. Now we're going to be taking a look at a more complicated version of this. And we're going to be taking a look at a couple of versions of this actually. Is how do we try to go ahead and add some data to it, right? So one method is just going ahead and finding the last node and add it to that. And that's going to be basically, we're going to be adding it where the list is empty list, right? We're going to be adding it. But notice that if we're adding it to the empty list, we got to do a few work here. First, our job is to add the data to the empty list. And then we're going to be taking the last pointer that's in the actual list and change this pointer to point to empty list, right? So that's our job. So we got to go ahead and try to figure out something like that. So how could we do that? So let's just go ahead and just call this def add. Again, this is like a linked list. Its parameter, let's say it's taking the start pointer as the parameter. All right. Now it's also taking the empty list as the parameter of the entire list. All right, we're going to be providing with all the data. Now let's say it also takes the data to add us. It's a data to add. Okay, so now it has all the parameters we need. So first we got to check that if empty list is less than 0, right? That means there is an empty list. All right, so we need to find if empty list. So if empty list is less than 0, or if it's greater than 9, right? So if that's the case, if it's greater than 9, and why is it greater than 9 in this case? Because we've got 9 pieces of data here. So if it's greater than 9, that means our empty list is full. And if we do less than 0, that means an empty list does not exist in this linked list, and we probably can't add any more data. We just need to create a new node to add it to this linked list. So that's going to be the major difference here. Then we want to go ahead and just, let's say, let's return false. Depending on your question, you're obviously going to be changing the algorithm. We're just trying to understand how this thing works. So now let's create a new node object. So you're going to call this, so obviously the name is same, so you're going to call this capital node. All right, so capital node is a node object of node. And let's see, we're going to be doing data to add, and obviously -1. That means this list is pointing towards nothing. This is going to be added to the end of the list, right? Because listen. All right. So what we are trying to do here is that this is the main. Let's say this is the main list. Okay. This is currently pointing to nothing, and then on the other hand, we've got our which is black. We've got our empty list, right? And empty lists, there are a couple of them, a couple of spaces left. So what we want to do is we want to add this to an empty list first, then break this list off, change this position to be none pointer, and then make this empty list the next pointer it points, and this empty list to point to null. That means we're breaking a empty list. We're breaking, let's say these are some extra tools we can use for our list. So we're taking one of the tools and adding it. It's like a nut or a bolt, and then you're just taking it and adding it to the list. Okay, so that's how you're trying to break this down. So that's why we put -1 at the beginning. Now what we're going to do is, let's say we're going to call this free list. Free list is going to be a variable that we're using to go ahead and find out where the list is still free. So that's going to be linked list, empty list, and then that's going to be the node of the empty list. Okay. So by this, what I'm trying to do over here is that I'm trying to extract the value that's here, right? Because we need to go ahead and now start pointing empty list. This is the empty list pointer. This was 5, and let's say this empty list pointer is 6. So we need to go ahead and now point to this. So we need to change empty list to 6. That's why we need to keep a record value of 6 over here, all right? So that's pretty important. So what you're going to be doing is from here, now we're going to say that linked list empty list. So in the first empty list, we're inserting this data to add. We're inserting big node. I'm just going to call it big node. All right. So big node n in this case. Okay. Once that's done, now we need to find that where the main list ends. So I'm going to put another variable named previous pointer, because what we want to do is we want to go ahead and find the previous pointer where the linked list is basically free, right? We want to go ahead and find out that. So let's first kind of develop this. So let's put this as 0. Like initially, just put this as some value. So while then we're going to be doing, in this case, we have inputted start pointer, right? So start pointer was our very first variable. So what we can do in this case is a little bit different, can be. So let's stay with start pointer. So while start pointer, this is not the actual start pointer, it's a variable that we're taking. What pointer? Okay, the spelling was there. Oh god. Okay, so start pointer is not equal to 1. Okay, we want to keep looping that previous pointer is going to be linked list, that current, like that particular start pointer, and then the node of that start pointer, right? We want to go ahead and do that. And what we want to do is we want to just update start pointer. And we just want to go ahead and put previous pointer is equal to start pointer. Okay, starting pointer or start pointer. So you could name this variable differently depending on how easy it's for you to understand the question, but this is how I'm going with it. All right, and then we've got the node over here. That means we're just changing start pointer. Okay, and we'll keep doing this. So what are we doing in this case? Okay, and start pointer is basically the previous pointer. So you could either keep it as start pointer, or I like to do is just do it to previous pointer. Now, what are we doing here? What's the purpose of this particular statement? The purpose here is that we keep looking through the linked list. Okay, so notice that the current pointer is like 0, and it starts from the very start pointer. So this goes to 1, then let's say it's going to 2, and it's looking through all the linked lists until it finds the one that has -1 in it. So once it finds -1, this stops, right? And so like the thing is, previous pointer gets updated to the value of this particular pointer. So that's why I was calling it previous pointer, because what we are doing is we are finding the one that contains, so let's say this is the 6th node. So we're finding the node that contains the null set. We don't exactly want this, because how else are we going to know the position of this? So we need to find the position of this, which is literally the previous pointing, right? So this box right here will contain the value 6. This is what is previous pointer, literally pointing to the previous pointer. So once we've determined that location, our next task is going to be going ahead and adding that particularly. So how are we going to be adding that? So let's say in linked list previous pointer, okay, what we are going to do is we're going to be adding empty list, right? So in previous pointer, okay, previous pointer, we're going to be adding empty list. That means the one that contains, kind of the null set over there, right? What we want to go ahead and do is we want to point empty list towards that, right? Obviously. And okay, not just in this, we want to point it to the node. So we want to update the node value of this. So That means what we are doing is this is the position 6. So we are going to 6, and then in 6 we are changing this value of 1 to the value of empty list. In this case, let's say that was, I don't know, 8. So you're changing that to 8. And the new empty list, all right, so our new empty list is basically going to be free list. And what I'm trying to tell you is that the empty list variable that we are going to be taking from this linked list, that's going to be changed, right? So we are changing empty list to go ahead. So this is our empty list to start from our free list value, which was already the next node value of this. So if empty list, let's say, was 8 and this value was 9, we are storing 9 in free list right here. So now we're changing empty list, which was previously 8 in our case, to 9. That means now this is our new empty list that starts from 9, and this is, let's say, 10, and then so on until and unless. So that's how we have successfully, and this is now pointing towards this. So we've broken this empty list successfully and attached it to our main list. So that's how this algorithm code is working, and I hope that's clear. To do that. And obviously, once something is added to the list, we want to go ahead and return, let's say it was added, so we go for true. Okay, so now let's go ahead and work on what if we want to go ahead and find a particular node, because that algorithm is fairly easier, right? So we have added a lot of stuff. Let's call this find, all right? And then obviously, I'm going to name this variable current pointer. This sounds a little bit more sensible, and I think that's how I've done it on my GitHub. Like, you're going to find my code there because it's a little bit the start pointer. It's like the same thing again and again. Feels a little bit confusing. And then let's say we're going to be doing data to find. Okay. And obviously, we do need the linked list in here, but it's up to you. You could just take linked list from here, or this is going to be otherwise used as a global variable. So while current pointer is not equal to -1, that means the linked list hasn't ended. We want to look at the main linked list. So if linked list, then we go for current pointer is equal to, we go to for data to find, all right? Then we want to go ahead and return, we want to return the position, right? So we just want to return current pointer. And if that's not the case, we want to go ahead and just go ahead and update current pointer. And what are we going to be going and updating current pointer to? So current pointer dot node. By that, what I'm trying to mean here is, let's take a look at our Epic Pen again, is that once we look through a list and we don't look for a node, and we don't find it, the current node, let's say, is 1. The value of current pointer, we call it pointer actually, is, let's say, 1. So we didn't find our data in 1. So what we're going to be doing is, in that current pointer's node, we're going to be assigning this to this new. So this was 2, pointing towards 2. So we change this and we put it to a 2. All right. So that's pretty much it. And that's how you can easily go ahead and search through a linked list, search through the entire linked list in that particular manner. Okay. So the final one that we want to go ahead and study is going ahead. Actually, final 2 algorithms have left is deleting something from a node, that means removing it completely, or and the other one is we're going to be working a little bit with add node to see how we could do something in order. Okay, so let's just call this delete in our case. So in the delete node case, let's go ahead and let's call it data to delete. Okay, so let's go ahead and do current pointer, because it's easier. So current pointer, it's a variable that I'm assigning, is equal to start pointer. Okay, because this is like global, it's right here. Now, we want to go ahead and find the node to delete first. Basically, just doing this find algorithm. So what we could do is we could just use the find algorithm. So since I'm doing this in one particular document, okay, I could just go ahead and call, let's say, position, and then I can just say find and data to delete. All right, data to delete, and let's say we're taking, oops, sorry, like this. All right, I could just do this particular code, but since we're doing it for the exam, let's just learn this once more. So again, while current pointer is not equal to -1, we keep searching. All right, so if it's not equal to -1, and so we're just going to update this slightly. Let's say we're going to do and linked list, because what if the data is not present? So linked list, we're going to do for current pointer is not equal to data to find, right? Because we're doing like, it's kind of like a linear search, right? So data to delete. In this article, data to delete. We're going to be doing, let's say, current pointer in our case, right? So what we can do is do another variable, previous pointer. Just like the previous one, we could do previous pointer, right? If you do previous pointer, it's just the way to calculate that what's basically that particular node where we're trying to delete the data. So this is going to be just going to previous pointer is equal to current pointer. And once we kind of do that with the current pointer, we will also have to do this. The current pointer is going to be updated. So which is going to be linked list current pointer node. We want to update that as well. Okay, till it kind of finds the data. So now, if current pointer is -1, okay, if current pointer remains -1, then what we want to do is we want to return false in this case. Why is that? That means data wasn't found. If current pointer has reached -1 in that case, the data hasn't been found. Or what you could do is current pointer is -1, and that's the case that the data hasn't been found in our case. So current pointer is going to be -0. Okay, this is a little bit because what if it has found the data to delete, but it hasn't kind of went ahead. So, okay, so we are going through this algorithm in the sense that we know that the data exists in the list, right? And then we want to go ahead and kind of delete it. If you want to go ahead and find the data, we can just go ahead and create this find procedure and put it inside delete and just check if the data we want to delete actually exists. But over here, we're assuming that the data actually exists. So if current pointer is -1, that means it for some reason couldn't have been deleted. That means data is kind of not there at all. Okay. Okay, if it has found the data, that means previous pointer, and it's no longer going to be changed. So current pointer is technically not going to be -1. If it has found the data, it's never going to be -1. If it has found it in the last one, there's still no chance that this is going to be -1, because if it has found it on the last one, it's not going to be entering the while loop, right? Because it's going to be sticking to the previous pointer. So it's not found the data yet. So that means we know that it's not going to be changing -1. So yeah, I think my algorithm is correct at this stage. So now, if that's the case, else, if it hasn't found it, so if current pointer is equal to start pointer. Okay, what's this? This means that if it's the very first data we want to remove, okay? If it's the very first data we want to remove. So imagine we've got the list, okay, we've got the list right here, and this is pointing to, let's say this is 1, this is 2, it's pointing to 2. And we want to remove the first data, which is 5, and the second data, which is a 6. If it's the very first one, then all we need to change is the value of start pointer, right? Because start pointer was previously pointing to 2. Now all it needs to do is it was pointing to actually 1. It needs to point to 2. It no longer needs to point to 1. That means a list, let's say this is the starting point, starts from here. And once you remove the chain from 1, that means 1 is no longer in this list. This thing no longer exists. So that's the advantage of that, right? So if it's on the very first, if it's on the start pointer, then all we need to do is change start pointer to linked list start pointer, and then the node stored in the start pointer. And if that's not the case, that means it's not the first one. Then we put another else statement, a lot of iterative statements. All we want to do is linked list previous pointer, that means the one that we want to delete, node is going to be changed to linked list current pointers node. Okay, so what does this statement technically mean? Let's have a look at our Epic pen once again. So imagine that we've got, okay, I think this is the thinnest. I think I don't want the thinnest one. Let's just change it to a little bit more. That's the fatter one, right? So let's say we were going through all the lists, right? So then it found the data, okay? So this is, let's say, 6, and this contains the data, let's say, 10. It has found the data 6. So our task is to go ahead and remove this, right? So this is previous pointer. That means it's pointing towards the previous element of this, which contains the address of the next element. So the previous pointer is basically 6 in this case. So what we're doing is we're taking previous pointer's node value, okay, which is the 6 value. So in this case, previous pointer is 6, and linked list current pointer dot node. So what is current pointer in this case? So current pointer is the next very node, right? It's the very next node of the linked list. Can you give me guys? So if we take a look at the algorithm, so what I'm trying to explain here is very simple. So if you just go ahead and take this, because someone had a problem in the class, is that basically we've got the data 6 here. This is 6, and this is, let's say, 7. This thing is pointing towards 7, right? So what we have done here by this algorithm is previous pointer basically contains the node. So previous pointer right here is this. So look at this part. Previous pointer becomes current pointer, or the value of current pointer goes to previous pointer. So at this point, current pointer, first of all, let's say, has arrived at, let's say, 5, right? And now the value of current pointer is changed to 6. So current pointer is kind of changed in advance, 6. And then previous pointer has the value 6 in it, right? This previous pointer has automatically got the value of 6 in it. Now what we want to do, and then we will go ahead and change current pointer. So current pointer is now changed to 7, right? So the value of current pointer is changed to 7. Once current pointer is changed to 7, what happens is with this statement right here, previous pointer, that means in 6, okay? So the previous pointer is basically 6, is changed, the previous pointer's node is changed to current pointer's node, right? So this right here is going to be the previous pointer, which contains the value of 6, all right? And this previous pointer's node is now changed to current pointer's node, which is basically 7, right? So after 5, it's technically pointing towards 7. It's no longer pointing towards 6. So 6 has gotten its change severed from 5 and 7. So 6 is no longer in the list. Previous pointer is basically 6. So we want to go ahead and just take this previous pointer from here, okay? Current pointer, okay? Current pointer is, it has arrived to, let's say, 5, okay? So current pointer has arrived to 5, and 5 is like previous pointer, all right? And then current pointer is like, at this point, is kind of 6. We've updated this to 6. So in this case, we are going to previous pointer, and we're just pointing this to this ultimately. So current pointer's next node. So what's current pointer's next node? Current pointer's next node is 7. So we're just instead taking 6 and changing this value to a 7. So we're pointing towards 7, okay? So that's how we're severing the chains, because in a linked list, we're not physically deleting the data. The data is kind of technically still in that linked list array, or if you're using a hash map or a dictionary, it's up to you. Okay, I personally think a dictionary is a more suitable option in this case, because node, you've got the node and the data in the dictionary and the hash set. But either ways, we're not here to talk about dictionaries today. So basically, this data is being transferred to 7 at this point. So the interesting part is that we're just severing connections. We're just severing what is pointing towards what, all right? So by that, we have automatically just pointed previous pointer to point towards 7 instead of 6. So we just severed its connections. And that's how we're going to do it. And now, current pointer, okay? So current pointer is going to have, let's say, its data to 0. So we can exit this loop right here. And what we could do is linked list current pointer, which is technically currently pointing to. So current pointer's data is technically 0. That means there's no data. This is optional. Since you've already severed the connections, this thing no longer exists. And in current pointers dot node, let's point it towards empty list, right? Because now that thing is the start of the empty list, because that area is kind of vacant. So if you want, you can put more data or other data into that. So let's just add it to our empty list section. So we're just going to put it as empty list, and empty list, the value of empty list is changed to current pointer, because empty list currently has the value 5. Let's say our current pointer's value is, I don't know, maybe 7. So we want to change that to 7. That's the start of the empty list, all right? Because you're just adding this to, because the node of the current pointer is changed to the empty list value. That means now current pointer is pointing towards that 5. So this thing is added at the beginning of that empty list. So the connections, if you kind of wire them up, is very confusing. But in terms of the code, it's actually very logical. And then once we deleted something, we want to just return true to say that we have kind of done the deletion process. It's complete. Okay, so that's pretty much how you can delete kind of a node. The last thing we want to do is we want to go ahead and look at this algorithm right here, our add algorithm. And we want to see that if we could change this algorithm slightly, if you wanted to do an ordered insertion, right? Like you want to have the linked list in order. They haven't asked any question like this till date, but they might in the near future, maybe this October, November, who knows. So let's go ahead and change this or update this. How we can do this? So now this part is free list, is list, and empty list is pretty fine in my opinion. And the empty list is going to be like so free list. We've got this empty list and node free list, linked list, empty list dot node. So that's kind of like the next pointer, right? The next pointer. So let's change this slightly, and we want to do is free list currently is the empty list. And we want to go ahead and change empty list to linked list. Then we want to go to empty list dot node. So if we are doing that, let's go ahead and do some changes to this particular algorithm. So first, what we want to go ahead and do is, again, we want to create a new node object. So let's just call it big node, all right? And then just do small node. And we're going to do data to add. And this, let's say, pointing to -1 once again. And we want to go ahead and add this to free list. Okay, this is like temporarily storing the data in the list, and now we got to go ahead and do the finding part. Okay, so let's go ahead and do is that while start pointer in our case, this is the pointer where we start searching. This is not the actual start pointer. It could be that, okay, I don't want to start from the very root pointer. I want to do it from the middle of the linked list. But logically speaking, that's how it always starts, with the very first start pointer. Okay, so while start pointer is not equal to -1, and so we want to do it in ascending order. Let's say we want to kind of organize it. Let's just do start pointer dot data being less than data to add. Okay, or you know what? Let's change this to current pointer. This is a much more sensible name, so I'm going to change it to current pointer. Current pointer. It's a lot more sensible, right? So you're going to do that. And we're going to do what is, let's just go ahead and do another variable, previous pointer. In this case, it could be 0, or, oh, sorry. In this our case, it's going to be current pointer. And current pointer is going to be updated to linked list, current pointer, the node of current pointer. So we want to go ahead and keep searching, all right? And this part is going to do the sorting part, right? We're just kind of seeing in ascending order. So now, what if it's a root pointer? So if current pointer, that means it's smaller than the root node, is equivalent to start pointer, which is, the main heading of our thingy. What we want to do is linked list free list. Okay, the one that we added in free list, it's very similar to the previous algorithm, right? If we wanted, it's very similar to this delete one, sorry, not the previous one, where we just change start pointer to the next one. So in this case, we're just adding free list before the start pointer. So what we want to do is we want to go for free list node, which is dot node, and change it to the start pointer value, right? Or actually not the start pointer value. We want to go ahead and change this to this start. Yeah, if current pointer is start pointer, that means it's smaller than that. So yeah, we want to go and put it in start pointer. And once we put this in start pointer, what we want to do is we want to do that start pointer is going to be free list. Okay, so we want to take the node number of free list and just put it in start pointer, because that's now where, right, like that's our start pointer, our new start pointer, right? The node address of free list. That's our new start pointer. Okay, don't worry, after we finish the code, I'm going to try to explain to you by drawing it using Epic Pen. And if that's not the case, we want to go ahead and do is in the linked list, free list, all right, next node, or the node inside that, is basically going to be previous pointer, right? Or actually not previous pointer. The previous pointer is going to be used to go ahead and find, where the first free list is going to be. The free list is going to be before the previous one because it's smaller than that. We were like kind of sorting it in ascending order. So what we want to do is link list previous pointer dot node, all right? And link list previous pointer node is going to be going ahead and change to the free list pointer, right? Because the previous pointer, okay, that we were doing is now changed to free list. It's pointing towards that. So we're just swapping the values. It's technically just swapping the values over here. And with that being said, we can just go ahead and easily return true. And we can also go ahead and return true in this case. There you go. Okay, so let's sort of understand what's happening in this new add algorithm. So let's say it is smaller than start pointers. This is our start pointer, and the node value that we're doing, it's smaller. Let's say start pointer contains the value 5. Our value that we have entered is, let's say, 4. All right, that means it's technically smaller. So what we want to go ahead and do is, this is in free list, right? This is in free list. So what we want to do is we want to go ahead and change the value of start pointer to free list. So start pointer previously was, let's say, in our case, it was 0. And free list is, let's say, in our case, is 5. So we want to change it from a 0. We want to go ahead and change start pointer from a 0 to a 5. All right. So it's now going to start at 5. And we want to go ahead and take a free list node. That means the node value that's here to point towards start point. And remember, we changed empty list to empty list.node. That means this free list is no longer the first empty list. It's going to be the next empty list that this free list was pointing to. We want to sever this connection and make this the first empty list. So that's why we have updated empty list at the very beginning of our algorithm. Because we know that whatever data we're inserting, we're going to be inserting it into the first empty list position out there. So that's why we updated it at the very beginning. If it's not the start pointer, let's take a look at what's going to happen. So as you can see, remember this previous pointer thingy? So it's going to be going for this previous pointer, and it's going to find out that it's, let's say, smaller. Okay, so previous pointer is going to be holding the value of this node, being, let's say, 4. And current pointer is going to be going ahead and holding the value of, let's say, 4 in this case. But this 4 is going to be changed to a 5. So current pointer is holding a 5, which is a 5 right here, and previous pointer is holding the value of 4 right here. So now what we want to do is free list node, okay? Free list in our case, I'm just going to use a different color. Free list, okay, whatever the data that we have put here. This is basically smaller than this value right here, right? This value is definitely smaller because as you can see right here, we're comparing current values data. So this is smaller. So previous pointer, free node, previous pointer is going to, so basically what we want to do is previous pointer is pointing to free list, right? And free list is pointing towards current pointer. So this connection is severed. So that means that this data is no longer here. This is how the new linked list looks. This is a lot more cleaner, right? From here to here. That's how we're changing the wiring. It's all a part of like changing a wiring. And there you go. It's now ordered, right? We're not adding it just at the end of the list. We're ordering it from here to here just as it should be. And with that, that actually covers everything you need to know for A-level computer science. So hopefully this is going to be helping you. And with that being said, I will be catching up to you in the next video. All right, so till that, this is the algorithms. And if you want to go ahead and find them, obviously they are done in my GitHub. You can just go ahead and go to my GitHub, go under algorithms, and then you can find all the ones that you needed. And obviously I'm going to be making future videos on linked lists, binary trees, trying to explain every single detail as much as possible. Till then, catch up in the next video. Peace.